Okay, so we're going to be getting started here in just a couple seconds. Everybody on this end is getting their spreadsheets up. It's called the statistics activity on your system. So if you're getting that up on through your course, then you should have that. So we're just waiting a second or two for the last couple people to be ready to go. Okay, so you will be needing to take notes as well on some of this. So you don't have to do it on the computer. You can do it by hand, that kind of stuff, but you're going to want some notes on this. What we're going to talk about today is correlation coefficient, fitting a line to data, and actually we're just going to take this last one off because that's not something that you're required to learn for the standards. So we're going to leave that one off. And we're going to basically what you're expected to learn from these is how to use the computer or the spreadsheet to do these items. That's why you're on the computer and using the spreadsheet today. So if if something's not working quite right, or you don't have it up yet, you can look off your neighbors until you get yours up, that kind of thing for right now. But we're going to move forward with that. And we're going to get away without an essential question today. So you can put no essential question today. I'm going to leave that off. Okay? And so, as we look at this, this is kind of giving you some direction. I'm going to actually cover some of the steps. We're looking at parts at a time. Remember from last week that we talked about association. You guys remember that? And association told us whether it was a positive association or negative, and then we looked at the graph, and you guys were able to look at it and tell me it's a positive association because the graph was going up, right? Or a negative association because the graph was going down from left to right. Remember that? Okay? So as we think about that, we're going to take that and we're going to build on that this week. Okay? So in order to kind of review that and get us set up, I gave you a spreadsheet and I gave you a bunch of numbers. Okay? And so what do those numbers represent as you're looking at that? What do the numbers represent? Grade and average score. These are average test scores. But you remember every year you have to pretty much you have to take the state test or that kind of stuff, right? And so it's like that's another thing. Where the state average state test scores for the different grades, they're different. Okay? So what we're going to do is, so we can figure out that association, is we're going to learn how to use a spreadsheet to get the graphs to come up, so we don't have to plot it ourselves. How about that? Does that make sense? Okay. So here's what you're going to do. You're going to highlight all the data, not the words, but the data. Remember from last time, you click on like the one, the number in the very upper right, the left-hand corner. Yeah. And you can go down and click on the one, hold the shift key, click on the bottom one, and the other one. And then there's a couple ways to do it. You need to highlight that data for both of those. Need both of them highlighted. Okay. Okay. All right, so we're going to highlight it. Okay. And then the next thing you're going to do is you're going to click on the word insert at the top. And once you have clicked on insert, you're going to click on the picture of the scatter plot that says scatter underneath it. So it's a different graph. Okay. And once you click on that one, what'd you get? Okay. Overall, what did you get? The whole thing all together. Okay. So, that's important to kind of see that. But let's talk about the association like we did last week. Is it a positive association or a negative association? Negative. So what if we had to describe it in words, what's happening here? As the what? As the grades increase, the score is going down. That's not a good thing, is it? Okay. So, as the grades increase, the score is going down. So that was the exactly what this next piece was. So you might want to jot this down because if you have to do this for the test, which you probably will, hint when we get there, I'll probably ask for that part 2 for you to be able to create a scatter plot. Make sure you get your directions down so you have that. You probably don't need the first bullet, but you definitely need the second bullet and everything after that, right? And on the other end, when you're ready to go on, you got stuff copied down, go ahead and put a check mark.
I think the drop over. That's a quick review on association, and we're going to use that as we move forward so that make sure you don't lose what's on your screen. So remember we said, the first thing I said was we're going to learn about the correlation coefficient. And that helps us know how true to things, how correlated or how much of a relationship is built between the two variables. Okay? And so what's one of the variables for our graph here? We've already talked about it. One of the variables is what? What are the two things we're looking at on the graph? The grades is one of the variables, and the scores is the other variable, right? So what we're looking at is the correlation coefficient is a number used to describe the direction and strength of the association between the grades and the, in this case, the grades and the scores. Okay? So we're going to look for that. We're going to see, is there a real strong association between the grade and the score? Okay? Or is there kind of a relationship there? All right? And when we write the correlation coefficient, we usually use the letter R to represent that, the small letter R. It's usually a number between -1 and +1. And that number describes the linear association. So when I say linear, what does that tell you? What do we see? What kind of might we see? Is it linear? A line. Excellent. Okay. If the R number is 0, there's no correlation between the variables, and that means those points are scattered all over the graph. So looking at our graph, do we have something that's scattered all over, or is it kind of getting close to looking like a line? Right. So our correlation is not going to be 0, is it? Okay. It's going to be closer to either the -1 or the +1. Okay. All right. So if you get to a -1 or a +1, you're basically at a straight line, and that means that there is a definite association, very, very strong association between the two. If that's 0, that would mean there's really no association because the number of points are all over the place. Okay? So people out in the real world use this all the time when they're analyzing things. They're analyzing things about sales. They're analyzing things about just all kinds of different relationships that they want to see if there's something that's connected. Especially if you're doing research, people use this all the time to check and make sure that what you're getting as a result really is correlated. So for example, before I came here this year, I was working with a project, and we did a lot of research with it. And we were checking to see if the professional development or the training we provided teachers had a positive impact on the student learning. And we found out that it did. But this is one of the things that we used as part of the numbers to help show that it had a positive impact. Okay? So that's what this is kind of all about. That you need to be able to interpret these things, because all out in that real world, all of a sudden you get all these graphs and tables and all that kind of stuff thrown at you about statistics. And unless you kind of have this understanding, somebody could really fool you with some of the numbers and the statistics on things. So that's why they're trying to kind of give you this information. So if the number here is, like I said, the number's going to be between -1 and 1. It actually could be -1 or 1. Okay. 0, there's no correlation. A negative value, the -1 kind of thing, or negative point something, is going to show a negative correlation. So if R decreases from 0 to -1, it's a stronger and stronger correlation, or relationship. And then same with the positive. It's going in the positive direction. So what kind of correlation do we have? Do we have a negative correlation or positive correlation? Okay, why? Okay, yeah, it's going down, and that's right. So it ties back into what we know about slope, doesn't it? Okay, the R is not the slope, but it does the positive negative part ties into what we know about slope, right? Okay, so that's keeping that in mind. What kind of a guesstimate might you make about a number for our correlation? You think it's going to be like a decimal? What kind of decimal number do you think it's going to be? Let's think about that for a second. We know it's not 0. We know it's kind of looking like a line, right? So where do you think it would be between 0 and -1? Let's think about a guesstimate of a number. I'm going to ask everybody. not going to just take it from one person. I'm going to ask everybody what they kind of think and why they think that. Okay? So what do you think? Okay, you think it's going to be pretty close to -1? Okay. Okay, so exactly -1? Or could it be like -0.5 or something like that? Okay. Yeah, it's not about the slope, remember. I just said it's about how close the points are to making a straight line. So what do you think? Let's keep going around the room. Your turn. We're just guessing. It's okay. Yeah, what kind of decimal number do you think it might be? So like a -0.5? Okay. Well, there's no 2, it only goes between 0 and 1. Okay, but could it be something between 0 and 0.5? I don't know. Go ahead. Okay. Why? It could be between 0 and -1. Right. Okay. So about in terms of the relationship to the graph, the closer to 0 it gets, the more spread out they're going to be. The closer to the 1 it gets, or the -1, the closer they're going to be to making the straight line. So, are you saying that, but if you're saying -0.3, you're saying that they're pretty spread out for making a straight line? Okay. Okay. So, do you want to change your mind about your decimal number? Okay. You want to think about it for a second and have me come back? Okay, good. Next. Okay.
I say around -6 to -7 because they're not too spread out, but they're not very close to each other, but you can obviously see the line going.
Okay, so maybe about -0.6, -0.7. Okay. Ariel, what do you think? I think -0.7. I like you made yours bigger so you could maybe see a little bit better too. That's fine. Next. Your turn. Okay, why do you say 0.2? Okay, but we can make an educated guess, right? We can make a good guess. 0.2 is close. Is that closer to -1? The -0.2, is that closer to -1 or closer to 0? Okay, and remember we said 0, the points were all spread over it, and there was no pattern. So when you say to me -0.2, what you're telling me at this point is that the points are kind of fairly spread out, and they're closer to being all spread out all over the place than they are to being a straight line. Okay? Do you have a change on the? Do you know what it is? You want me to come back to you? You want to say -0.8? Okay. Next. Okay. All right. Let's come over here. -0.5, Justin? -0.5? -0.7. Okay. Got to come back to my last person and didn't. What do you think? Think about -0.7? You guys want to figure out how to do that? Find out what if you guessed right. All right. So let's figure out if you guessed right or not. We already talked about what kind of correlation it is. We know it's a negative correlation, right? Oops, I'm not there yet. So I'm going to bring the spreadsheet up here and share that with everybody. That's not what I wanted. Where'd it go? That's not what I wanted. Why is it not coming up? Okay, I'm just going to do it this way. You guys are going to have to follow this on the other end because for some reason it's not linking to the shared screen. But maybe let's try it one more time. Just see. There it is. Okay. All right. So, let's click on the D3, and we're going to type in correlation coefficient. All right. And then once you've done that, click on the cell right below it. Okay. Okay, so remember last time, a couple of times ago, when we started doing me, and mode, we found all those buttons that help us do shortcuts? Okay, you remember where that was? Okay. We find that under formulas. So go to formulas. Okay. Did everybody find the formulas and click on formulas? And looking at that, what do you think we need to do? No, we're not saying add them all together. Statistical. So now we use formulas, statistical. We can find that in two places. You see the left, it says X. Where it says X. You can click here, or you see where they like go books there and more. You click on that and then statistical. Either one works. Okay? So what we're going to do is we're going to go to formulas. Did everybody find that one of those now? Okay, so you went to formulas. Then you either chose the insert function or you found the more functions and clicked on statistical. If you did that one, you're going to get a whole list of these things. The one we're looking for is the one that's CORREL. So click on that, then you should get a little window that comes up. CORREL. Yep. Okay, then you have something that talks about arrays. And the array is just the SOAD numbers that you're looking at. And so just like we did with the mean, median, and mode, we're going to click on the last one, hold the shift button, and click on the bottom one. So I'm going to click on the first one. I'm going to move this so I can scroll. I'm going to scroll down to the bottom of that column, hold the shift button, and that, or you can highlight like you guys know how to do. Either way, it's usually easier when you have to scroll to do this. Okay? And now you have the numbers you want for your array. And I have a slide up here that goes through these steps in just a couple minutes, okay? So we're going to do it together then. So what are you going to, suppose it's going to go into array number 2, the second column. So go ahead and do that, okay? Okay, and what that did is it put in the formula so that it will calculate that correlation coefficient for you. You don't have to know how to do that right now. It gets pretty complicated, right? You know, it gets complicated like that, but at least you know how to calculate it and have something calculated for you. So once you've done that, what are you going to push? Okay. All right. So who is closest? I heard somebody say something else. Who is closest? Somebody got close with -0.7, but somebody said -0.8, didn't they? Was that you, Max, that said -0.8? We knew it was negative because we were talking because the graph went down. So, yeah. Okay. So actually, it's almost 0.9, isn't it? So it's really close to -1. So is there a strong correlation between the grade going down over? in the grade you're in. Okay? So there's a very strong correlation there, isn't there? Okay? So we're going to go back. Go back here and pause my sharing. So we asked about kind of correlation, and we found out it's a very strong correlation, right? It's a negative correlation. Okay. So let's make a little note of that with our spreadsheet. That you have a very strong correlation. Okay. That this is negative, but sometimes we want to make sure we're being very careful because we don't want to make correlation does not mean the same thing as causation. And in this case, it doesn't necessarily cause your score to go down. No, that's not the thing that causes the score to go down. But we know that behind the grade level, we're more sure it's going to go down. That's not necessarily the cause. We can start the reason for doing that and looking at these things is to know how to ask those questions. Because what's a good question to ask? If you know that there's a relationship between the grade and the score going down, what's a question you might want to ask to find out the answer to about that information? Why what? What's causing it to go, why is it going down? Right. And so what might you do, what might be some things you might think about might be possible answers for that happening? Why is it going down? Why do you think it might be that? Why do you think it might be happening? Okay. You might be getting a whole lot of temper. Could be. So I can do some research on that and see that might be true, couldn't I? See if that's really the reason or not. What else might be the reason? What's happening? What's my responsibility? You're not going to figure it out. This is what researchers do all the time. You ask yourself, well, what happened? And then you ponder it and you check it out and see if it has to work. And people do this in their actually real jobs all the time too. They look at this stuff and they say, well, what might happen if we change this? And then they do some math and stuff to figure it out. Okay, that could be, couldn't it? Maybe that there's something good in the class that's hard to do to the evaluation of these, so that would be another thing to make it go not with that. Okay, what else? What else might be something that might have been causing that?
Kids not having studying the guy.
The kids not having studying for exams, you could do some research on that. What else could be a reason for that happening? Okay, so again, there's way more problems in terms of time, the timing of it, and that kind of stuff, because the next dollar doesn't fit dollars that needs to be looked at, isn't it? Okay, what else? Anything else? Okay, so you guys have lots of different thoughts and ideas about this. Okay. Here. But you have that one graph and that relationship right to a whole bunch of questions, and we can probably think of a few more that some of you maybe are a little too shy to share. Okay? And that's kind of how things work out in the real world with this kind of stuff, with all those kinds of things. I mean, you're like Coca-Cola and Pepsi, products, they look at these kinds of things and they analyze these kinds of things. And they ask all these kinds of questions to try and make their product better or sell their product. It's the product itself because they want to make money, right? And they're trying to find ways to make more money. So they do these kinds of things. Car manufacturers want to do these kinds of things, whether it's to figure out ways to make the car more efficient in terms of gas, or whether it's to help them sell the product better, or what kinds of things. They use this type of stuff all the time to help with that. Okay? So, and so you see how those, you can see how your questions just kind of naturally started coming out from this, didn't they? Okay?
All right. So we know that one didn't cause the other. So causation, you guys need to do it this down, means that a change in the value of one variable results in a change in the value of the other. So your grade didn't cause the other thing to happen, right? The grade level did not cause the test grade to go down necessarily. Okay? Correlation means that one variable is related to the other, which in this case it is, right? Okay? So, and here's another example. A researcher finds a negative correlation between the amount of money a person spends on sneakers and the number of cavities that they have. Yeah, the amount of money you spend on sneakers does not cause you to get cavities, right? Or it doesn't cause you to have fewer cavities, right? Okay. Yeah. Okay. This is kind of a really silly example, but it makes the point, doesn't it? So this would be, there's a correlation there. There's a relationship. One's related. There's a relationship between that's happening there, but it doesn't. One doesn't cause the other one or prevent the other one, right? Okay. So let's see if I can. Hope I didn't actually get the slide inserted in the wrong spot for that. Okay. So here's the directions for finding that correlation coefficient. And I chose the cell D3 and D4, but you can put by any cell. I just want to make sure that I'm aware that the graph going to pop up. So when you have this taken care of, make sure you give me a quick check so I know you're ready to move on. Yeah, we have to add energy a little bit of some parameters to make sure we have some numbers you're working with. Project instead of a part 2 test. Good like that? All right. Yeah, this is something we can kind of do a project with. Yeah, it's pretty great. Is there a relationship between certain things? Right. Make sure you remember how to do all the button and all the buttons. Here's pretty much ready. Looks like. All right. So we found the correlation coefficient, and so again, what does that correlation coefficient tell us? It tells us, and for this case, in our situation that we looked at, there's a real strong negative correlation between those two items, right? It's strong because of the number. It's closer to -1. Okay. So the last thing we need to do is look at a regression line. We're going to actually get to put that on with our spreadsheet as well. Okay. And just a couple quick things that we need to know before we do that is that the independent variable, because remember that's the one with the input number, right? Remember that impacts the other number, is called our explanatory variable sometimes, and the dependent variable is also called the response variable. So thinking about it in our spreadsheet, which one's the explanatory variable and which one's the response variable? That's what somebody's highlighting their vocabulary order, so you can find that, but the difference point is that you have to throw it, you have to form the movement, you know, you can point it, you can do that kind of thing. So did you guys decide which was the explanatory variable and which one was the response variable for our spreadsheets?
Average score, and the response variable would be the grade.
Why?
Because
which one has the impact on the other one?
the grade has the impact on the average score.
Okay, so the grade would be the grade would be the explanatory, and the grade level would be the explanatory, and the score would be the response. Because we know as we go further along in the grade levels, the score is getting lower. Because that's the grade. The grade level is what's having the impact on the grades. Okay, so we got that. So what is a regression line? It's a line where the points of the correlated variables tend to fall. So we've got some vocabulary we're having to get down here. And then it says how do you find the equation of the regression line? Mm-hmm. What? Probably, let me have to ask for
So here's ready. Okay, so I left off a couple of instructions here we have to add. So
You might want to write these down as we go. I'm going to bring up the sharing again. Okay. Now I didn't put my table on here, so let me get my chart on here, or my graph on here. What you need to do is make sure you click on your graph. So that's the first direction. Is click on your scatter plot. Okay, so it's the one that's highlighted, and then you can see at the top where it says chart and it says design. Once you highlight, kind of clicked on your graph again, and we want to choose the one that looks like it has a line in it, because we're looking for a regression line, right? So choose the one, and actually mine's not the third one because it's got shrunk, but it's got the third one over, they're in a line. So you can get a line on there.
okay. Line. All right. So we've got this line now, and we know from before we can find the equation of the line, right? You've got to find the equation of the line.
First we have to know is the what? Slope. Y equals mx plus b, right? We need the slope, and then we can figure, if we know the slope, we can figure out the y-intercept, especially since we know the names of some of these points. Okay? And I can actually make that bigger if I want to, so you can see that more easily. Okay, so I can see that this is going to the bottom point here, and look at what happened when I pointed to it. What happened when I pointed to the point? It told me the name of the point, didn't it? Okay, and if I go down here to the other point, down here, that the line is actually touching in this case, it gave me the name of that point as well. Can I use that to find the slope of the line? I can, can't I? Okay, So when you're going to do this, you're going to find the slope of the line. You're going to find the points that are closest to the 2 points that are closest to the line. In this case, the line went right through those 2 points, didn't it? So those are the ones that choose. If it didn't go through those 2 points, we'd want to choose 2 other points. And it also goes right through this point right here, doesn't it? But I'm not getting that one because it's not going to help. They want us to use the end ones. It's giving us some other stuff too to find some of the slope. But you can also figure out those numbers from your table as well, because we know that the last ones are the 11th grade one, and it's right the number that's right in the middle, right? So we can look at our table and figure that out as well. So you remember how to find the slope? Yep, y1 minus y2 or y2 minus y1 over x1 minus x2, or the other way around, depending on which one you start with. So let's go back to our whole thing here. So we were able to get the line to come up, and now we need to find the equation for that line. And so to do that, we would say the y2 minus the y1, right, over the x2 minus the x1. So we picked the 2 points. I don't remember what the numbers were, but we can figure that out. Let's see. One was 383. So we have 2 comma 383. And the other one, 11, 282. Okay, so we can use that and then calculate the slope. I can say 282 minus 383 over 11 minus 2, and I get 100 over negative 100, right, over 9. So then I have my slope, and I want my calculator to figure the rest of it out, because now I have a point, I have a slope, and I also can pick one of these points. You guys remember doing that? Picking the point and using that to figure out the rest of this. That's your x and y, right? And you have the equation y equals mx plus b. So the first thing we did was we found our slope, right? And then we'll pick an x and a y, and we'll plug it in and figure out what the b is. Yes? Yes. You're right. I was thinking the same too, but you're absolutely right. Thank you for catching my mistake. Okay? So I didn't put the notes down for how to do this because this is something we've done in the past, but just kind of refreshing your memory. Okay, you may need to look at your lesson, your actual lesson, to refresh your memory and get the actual step-by-step. Okay? Make sure you do that, because if we do a project, I'm going to ask you to be able to come up with this line. Okay? Could you create an equation on your spreadsheet to calculate it for you? You think? That's just something to try. That's something to try. Okay? I didn't show you how to do it, but I bet you could create an equation to come up with that. Okay? And you would have to create it. There's not a button for it. All right? So we lost a little bit. We also call that line of regression a line of best fit, just so you know. And that is it. So, quickly write your summary before you go. Write your summary and your answer to your essential question. Okay?
Okay, that's great. So it's a summary today. It's just a summary today, not both of them. So let's quickly summarize what we talked about today in class at the bottom. Okay? Any other questions? Did I still use the computers and do some stuff with the computers? Okay? So, should you do something? You are